Alright, so here we're going to review 4 math ratio problems. I'm just going to zoom in on each one and talk about it and show you how you do it. JT can run 3 miles in 18 minutes. How far can he run in an hour? So I would solve this using a ratio table. So 3 miles over 18 minutes. And you got to kind of scale up because an hour is 60 minutes. So my goal is to get to 60, but 18 doesn't go into 60 easily. So I'm thinking, wait a minute, I could probably bring this down to 6, right? And then 6 can go times 10. So 18 divided by 3 is going to be 6 minutes. And then you do 3 divided by 3, and that will give you 1 mile. So it's 1 mile in 6 minutes, and then you got to go to an hour, so then you're just times 10. So when you do times 10, you're at 60 minutes, that's an hour, and then times 10 would be 10 miles. And so then it says how far can you run in an hour? It would be 10 miles. And that would be your answer there. So for the next one, we go down here. You have this recipe that makes frosting for 12 cupcakes. So then the problem's saying that Mr. Donnelly is making cupcakes for Evan's birthday. In order to make the frosting, can't read the whole problem. He follows the recipe above. Okay, so I'm using this recipe. How much butter would he need if you're going to make 21 cupcakes? So again, it's just a ratio. We're looking here at the butter. 4 tablespoons of butter will give me frosting for 12. So I set up that ratio 4 to 12, and then I just need to scale it up to 21. But 12 doesn't scale up to 21 nicely. So I sit there and I think, okay, well I could, oh wait, I can just divide them by 4. So if I divide by 4, I get 1 tablespoon of butter, and then divide 12 by 4, and I get 3. And then 3 scales up to 21. So 3 times 7 is 21. And so 1 times 7 is 7. And that leaves me with the 7. So when it says how much butter would he need, it'd be 7 tablespoons. So you need 7 tablespoons of butter. Again, you just start with a ratio, and you look where you got to go, and then you realize, oh, 12 doesn't work. So you scale down to a number that does work, and you get there. All right, on to the third problem. Now this one's a bit lengthier in terms of the thinking you need to do. So the first thing you have is a woman is making trail mix for a party. The bowl holds 40 cups of trail mix. The bar model represents the ratio of chocolate chips to Chex cereal. So this is the ratio, and this represents the whole bowl. So all of these together is 40. So you're like, okay, all of these are 40 cups. And then you know that there's 1, 2, 3, 4, 5. So you have to do 40 divided by 5, which equals 8. So there's 8 cups in each box, because in a ratio you have like 4 that are equal, 4 equal parts to 1 equal part. So how many chocolate chips and how many cups of Chex cereal are used to make this bowl? So this bowl, for chocolate chips, you just need 8. So 8 for chocolate chips. And then Chex cereal, you would need 1, 2, 3, 4. 4 times 8, so 32 cups of the Chex. Now it says each person gets 4 ounces of trail mix. So how many servings could the bowl hold? Alright, so this just goes back again to the cups. And do you know, like 4 ounces? 4 ounces times 2 is going to equal 8 ounces. So if I set up like this ratio, 4 ounces per serving, and then I do that times 2, I get 8 ounces, and then so that'd be 1 serving. 8 ounces is 2 servings. And then I know that 8 ounces is a cup. So for every 1 cup, it equals 2 servings. And then I can say, okay, well then if I have 40 cups, that's 1 to 2, but that 1 needs to go to 40. So it's times 40, and then 2 times 40 is 80. So there'd be 80 servings. So if each person gets 4 ounces, how much could the bowl hold? And how many servings? So you'd say 80 servings. And that's how you'd figure that out. And then finally down here, Mr. Donnelly and Mrs. Rogers are both traveling the same distance for the holidays. All right, who will, so then it says Mr. Donnelly's traveling rate, and Mrs. Rogers says who will get to their destination fastest, how do you know? So it doesn't matter where they're going because they're both traveling the same distance. We just don't know what it is. So what we have to do is to figure out, okay, if this is Mr. Donnelly's rate and this is Mrs. Rogers' rate, who's faster? Well, they don't have the same number of hours, so we have to get them to the same number of hours. So I'll label this work as Donnelly, and that's 294 miles in 6 hours. And the quick way to think about this is to simply use your calculator and come up with miles per hour. So 6 divided by 6 is 1. And then you do 294 divided by 6, and you put that into your calculator. So 294 divided by 6 is 49. So that means that Mr. Donnelly goes 49 miles in 1 hour. And we do the same thing with Mrs. Rogers here. Okay. So Mrs. Rogers is 549 miles in 9 hours. So at the first look, like you look at them, it's like, oh yeah, she traveled more, but she drove for more hours. So we don't know that she necessarily is going to get the same distance faster, right? I mean, the distance could be like 600 miles, and maybe Mr. Donnelly gets there faster. He's doing 49 miles an hour. So to get to per hour, we divide by 9. So 9 divided by 9 is 1 hour, and then 549, you just enter that into a calculator, hit divide by 9, and that's 61. So now we know that Mrs. Rogers does 61 miles per hour, and 61 is greater than 49. So who will get to the destination fastest? How do you know? Well, 61 is greater than 49, so Mrs. Rogers. And that's how you would solve each of these 4 problems.